Since logarithmic and exponential functions are inverses of each other, then they can be used to simplify terms that contain one or both terms. So remember in our inverse functions chapter, we reviewed the composition of functions. And when we have two inverses and we use the composition of functions, the results will be the independent variable that was applied, x. So if we have f of the inverse of x, that will be equal to x because the function and the inverse function negate each other. And the same thing will happen if we switch the order of those functions. The inverse of the function of x is equal to x as well. So if you have two inverse functions that are applied to each other, regardless of the order, the variable on the inside will be the result. So we know logarithms and exponential functions are inverses of each other. So this helps us see that if we have the log of base b of b to the x, we have our first function on the outside here, the log, and the exponential function on the inside here. This function and this function cancel each other out, leaving us with the exponent x. And if the exponential is the first function and the log is the second function, then the result is the argument x that is in the exponent here. So we are going to walk through a few scenarios in which we are canceling out the log and exponential function to get the exponent, or to negate the exponential function in the logarithm to get the argument in the exponent. So let's walk through a few examples. If we had the log of base b of b raised to the power of y, the log to base b and this base here cancel each other out, leaving us with the exponent y. If we had a numerical value for the base, such as this one, the log of base 2 of 2 raised to a power of -5, -5 would be the result here, once the log and the exponential base cancel each other out. The base can also be a variable, such as the log of base of x to the fourth. These cancel each other out, leaving us with the exponent 4. If the first function is not the log, but instead the exponential, such as in this example, the base 7 and the second function in the exponent, the log here, will cancel each other out, leaving us with the argument in the log and the exponent here. So 7 raised to a power of a log with a base of 7 of 2 will be equal to the argument in the exponent 2. Another example, let's say we had 13 raised to a power of a log of base 13 of x. This base 13 and the log of base 13 cancel each other out, leaving us with just x. Let's now walk through an example from the beginning. You'll be asked to simplify an expression such as the log of base 2 of 2 raised to a power of -6 plus 9 raised to a power of a log of base 9 of 12. So we want to use the inverse rule to simplify this term, use the inverse rule to simplify this term, and then we can add together the resulting terms. So step 1, replace the logarithmic term with the value of the exponent. So for this term, we want to replace this logarithmic term with the exponent -6. Since the log of base 2 of 2 cancel each other out, leaving us with just -6. And now we can work on the second term, 9 raised to a power of a log of base 9 of 12. We want to replace the exponential term with the value of the argument of the exponent. So we'll replace 9 raised to a log of base 9. Replace this whole term with the argument 12 that is in the exponent. So we wind up with -6 plus 12. And once we evaluate this expression, -6 plus 12 is equal to +6. So we find that the log of base 2 of 2 raised to a power of -6 plus 9 raised to a power of a log base 9 of 12 is equal to 6. And that is how we go about using the inverse rule to simplify logs. Let's now have you try a few practice questions. Simplify. Question number 1. -2 of a log of base x of x to a power of 3 plus x raised to a power of a log of base x of 9. Question number 2. 4 times a log of base 3 of 1 divided by 3 squared. And question number 3. The log of base 7 of 7 raised to a power of 3 to a power of 4 divided by 11 raised to a power of a log of base 11 of 2 to a power of 5. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We were given -2 of a log of base x of x to a power of 3 plus x to a power of a log of base x of 9. Step 1. In this first term here, we want to replace the logarithmic term with the value of the exponent, which is 3. The log and this base here cancel each other out, leaving us with the exponent 3. So we wind up with -2 times 3. And now we can simplify the second term. So we want to replace the exponential term with the value of the argument in the exponent, which is 9. So we wind up with -2 times 3 plus 9. And when we evaluate this, we wind up with -6 plus 9. And -6 plus 9 is equal to +3. So the answer to question number 1 is -2 of a log of base x of x to a power of 3 plus x to a power of a log of base x of 9 is equal to +3. That is the answer to question number 1. Let's now have a look at question number 2. We were given 4 times the log of base 3 of 1 divided by 3 squared. We want this argument to have a base of 3 to match this base. So step 1, we want to make the exponent of the argument negative. 2 here is positive in the denominator, but we can have the reciprocal, which would be 3 to a power of -2 over 1. And now our base 3 matches this base, so these can cancel each other out. So we can replace the logarithmic term here with the value of the exponent -2, giving us 4 times -2. And now when we evaluate, 4 times -2 is equal to -8. So for a question like this, if you are given a fraction for the argument, you can make this base the base in the numerator by making this exponent negative. So that is the answer to question number 2. Let's now have a look at question number 3. We were given the log of base 7 of 7 to a power of 3 to a power of 4 divided by 11 to a power of a log of base 11 of 2 to a power of 5. So we'll start in the numerator. Inside of these parentheses, we want to replace the logarithmic term with the value of the exponent 3. So log of base 7 of 7 can be replaced with just 3. And now this is raised to a power of 4. So we have 3 to a power of 4 in the numerator. And now in the denominator, Since this 11 and this base of 11 match, we can cancel those out, leaving us with the value of the argument in the exponent, which is 2. And that 2 is raised to a power of 5. So once we simplify the logarithmic terms in the numerator and the denominator, we can now evaluate this fraction. And in the numerator, we have 3 raised to a power of 4, which is equal to 81. And in the denominator, we have 2 raised to a power of 5, which is 32. So we find that the answer to question number 3 is 81 divided by 32.